Hey, this is Math 6, Unit 5, Lesson 9, using the partial quotients method. Okay, so we're going to be talking about partial quotients today. Again, we'll be looking at what we call long division later on. It's just not quite yet. So we're looking at partial quotients to start things off with. Okay, so before you talked about division being making equal sized groups, and that's what we're going to continue to do today, is making equal sized groups with the different numbers we are going to be using for our quotients. So first, in activity 1, using base 10 diagrams to calculate quotients, it says Elena used base 10 diagrams to find 372 divided by 3. She started by representing 372. We can see there's 300s, there's 70, and then there's 2 right here. So it's we're just going to walk through what we see here visually. The next says that she made 3 groups, each with 100, and then she put the 10s and 1s in each of the 3 groups. Her diagram for 372 divided by 3 is right here. We can see the 3 hundreds, right? Here's the 100, 1, 2, 3. That's easy enough to put in our group. 1, 2, 3. These are our groups. Group 1, Group 2, and Group 3. Now for the 7s, or the 10s, we know she had 7 of them. 1, 2, 3, 4, 5, 6, 7. And what she does is she puts them here. 1, 2, 3, 4, 5, 6. And then the 7th one is not really there, is it? I'm going to just draw it right here for now just so we can kind of see where that is supposed to be at. So this one is not really in the picture, is it? For the 1s, she has 2 1s, and we can see 1, 2. The 2 1s are here. So with your partner, it says Elena's diagram for 372 has 7 10s. The one for 372 divided by 3 has only 6 10s. Why is that? So why is in this picture here she only has 6? What happened to this missing one? Okay, the other thing that's happening here is we would ask ourselves, where did these extra 1s come from? Because that is the question of what we're talking about here today. She has some extra 1s, and then what happened to the 10? So this one's disappeared, and instead we have that right there. So talking to your partner, what do you think she's done here? What has been her idea? Okay, so hopefully in your discussion you talked about how it looks like she took this extra 10 bundle and she unbundled it and turned it into, in our case here I just draw circles, it's faster, into 10 1s. And so this one became those extra 1s, which allowed her to then make the equal groups of 4 and 4 and 4. That's what she did there. So she ends up with 300s, right? She has 60 10s and actually 12 1s, which is the same as 372, right? If you add that up, 360 and 12, what do you have? There's 2, there's 7, and there's 3, and that's the number she's working with, 372. Okay? So, just kind of an idea of how you use base 10 diagrams in order to break apart some of the base 10 blocks into smaller units or smaller groupings there. Let's take a look at how we use what are called partial quotients. It says here that Andre calculated 657 divided by 3 using a method that was different from Elena's. Okay, so Elena would have done 657 and would have had a different kind of thing. So Elena's method for 657 would look something like this. Okay, so here's a picture of Elena. So what would Elena have done? Elena, if she had 657 divided by 3, would have taken the 600s and would have said everybody gets 100 blocks, 1, 2, and 3. So that's good there. There's the 100 blocks there. Okay. And then she would have taken the 10s and said, okay, cool. Then we have 1, 2, 3, and then we have 4, and then 5. Well, what happens to this guy? Well, he's short a little bit, so that's not going to be very balanced. And then she had 7 1s. So you could do 1, 2, 3, 4, 5, 6, and 7. So that's not very balanced either. So Elena's method, a couple things she could have done. She could break apart the 100 stick, or she could take these ones here, these guys, and turn them into 21 blocks, right? So we could say, keep going here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And so Elena's would look something like this, okay? Where she would have 200, everybody gets 10, and then everybody gets 9 all together. So we add those up, you end up with 219. So that's how Elena would probably do it if she's using the blocks there, okay? She would have taken these ones here, these extra 10 sticks, which are a total of 20 because there's 2 of them, and then put them into groups of 1 so everybody has the same exact number of hundreds, tens, and ones. That's the way she would have done it here. Now Andre does it a little differently. Andre starts by writing 657 divided by 3. And we can see that he then subtracted 3 groups of different amounts from 657, starting with 3 groups of 200. So he says, okay, in the 657, I know that there are 3 groups of 200 inside of here, because 200 times 3 is 600. So he has what's left is 57. Then he decides, okay, well, then I have 3 groups of 10 and 3 groups of 9. So 3 groups of 10 times 3 is 30, so he gets rid of that, and he has 27 left, and then he knows that's 3 groups of 9, which is going to be 27 to get 0. And then Andre calculates by, in a sense, adding vertically this way, 200 plus 10 and 9 to get 219. That's the way he got his solution there. Okay, which does match what we saw before in Elena. She had 219 as well. So, as you, with your partner, have a little discussion. Andre subtracted 600 from 657. So what does this 600 represent? Okay, 600 represents what? Well, in our case, it represents what? 6 groups of 100 is what it stands for there. It also represents 3 groups of 200, if you want to think about it. Okay, that way there. Andre wrote 10 above the 200. So right here, talking about this part here, he wrote a 10 above the 200. And then subtracted 30 from 57. So then he did this part here. How is the 30 related to the 10? How is this related to that? Well, the 30 comes from being what? 3 groups of 10. That becomes the 30. 3 groups of 10. So what do the numbers 200, 10, and 9 represent? Well, this is 3 groups of 200, 3 groups of 10, and 3 groups of 9, which totals up to 630 and then another 27, which those combine together to make 657. Alright, and the 0 at the bottom of Andre's work signifies that after doing this here, there's nothing left over. There's no remainder, as we would say. Okay? So, using Andre's method, let's see if we can do 896 divided by 4. The trick with this method here is you want to make sure you leave yourself enough room up above your equation, okay? So I'm going to write 896, I'm going to divide it by 4. I'm going to leave myself some space up here to use Andre's method. So I think to myself, okay, how many groups of 100 are in, how many groups okay, so how many groups of 400 are in 896? Okay, I would say that there are 2 groups of 200 groups of 4, or 4 groups of 200 inside of there. So 4 times 2 is 800, right here like that. And I'm going to subtract 96 from this. So then I'm going to ask myself, okay, 4 and 96, how many groups do I have here? In this case here, I might say that I have 20 groups of 4. 20 groups of 4 is going to be 80. And so I can subtract this. 96 minus 80 is going to be, in our case here, 16. And then how many groups of 4 in 16? There are 4 groups of 4 in 16. So we're at a 0 remainder. And so now let's add these up vertically here. 0 plus 0 is 4, 0 plus 2 is 2, and 2 plus nothing is 2. So 896 divided by 4 is 224. Okay? Does that kind of make sense there? Right? Alright. So we had 4 groups of 200, 4 groups of 20, and 4 groups of 4. And that's what these are here. 4 groups of 400, 4 groups of 20, and 4 groups, 4 groups of 200, 4 groups of 20, and 4 groups of 4. And that's where we got what we got. Alright, let's look at the next one. Find the quotient. 1,332 divided by 9 using one of the methods you've seen so far and show your reasoning. Okay, so let's take a look here. Let's go 9 divided by 1,332. Okay, so in this case here, I'm going to go ahead and say that there are 9 groups of 100 inside of here. And that's because 9 times 100 is 900, and I know I haven't really gone over. If I did 2, if I had said there were 9 groups of 200, that's going to be a total of 1,800. That's going to be too large. So I can't do that there. So I do have to think a little bit about what's going to work. So I have 9 groups of 100, and so I'm going to take that out of my total. So I end up with 2 and 3, and 13 minus 9 is 4. Okay, so now I'm looking at the 432. Alright, now do I have any groups of, 100 in here? How many groups of 100 do I have? Do I have 9 groups of 100 in there? Nope. Do I have, what else do I have? Well, I know that 9 times 4 is 36, which makes 9 times 40 equal to 360. So I have, in this case here, 40 groups of 9 still inside of there. So I can subtract that, 40 groups of 9. Okay, so 2 minus 0 is 2. We're going to borrow here. 13 minus 6 is 7. Okay, and inside of 72, I have 8 groups of 9 inside of 72. So I have 0 left over. Now I'm going to add this up vertically. 0 plus 0 is 8, 0 plus 4 is 4, and 1 plus nothing is 1. So I have 148 as a solution there. Alright, let's move on to number 2. There we go. And so we're going to divide these up, and it wants us to at least use the partial quotient method at least one time, which is what we've been doing here above. So let's do the first one. We have 5. And we have 1, 1, 1, 5. Okay. First of all, there are 200 groups of 5 inside of there, because 5 times 2 is 10, and we can write down that as 1,000. Okay, so 200 groups of 5 is 1,000. So when I subtract, I have 115 left. Inside of 115 are actually 20 groups of 5, because 20 times 5 is 100. So I can leave that right there, and we could say that leaves you with 15 left there. Inside of 15 are 3 groups of 5. 3 times 5 is 15. We subtract, we have 0, so we have no remainders. Now let's add this up vertically. 0 plus 0 is 3, 0 plus 2 is 2, and 2 plus nothing is 2. So we have 223. Our next one, we have 7 and 665. Okay, now in this one here, do I have any groups of 100? Do I have 100 groups of 7 in here, right? If I did 100, let's think about this. 100 times 7 is 700. Can I subtract that? I can't do that. So I know that already I can't use 100, so I have to go with some 10s there. And the way you want to think about this is like 7 times what will get you to close to 66. I know 7 times 9 is 63. So we're going to do 90 groups of 7, which is 630. That puts me close, not going over. We subtract, we have 5 and 2. Now, in this case here, 5 and 2. Why did I put 2? I don't even know. Let's put a 3 there. A 3 there. So, how many groups of 7 are in 35? That would be 5 groups of 7. 5 times 7 is 35 exactly. So no remainders. Add these vertically here. 0 plus 5 is 5. 9 plus 0 is 9. So we get 95 as an answer. if we're doing our math right. And our last one, we do 16 and then 4, 3, 2. So 432 divided by 16. And in our case here, I think about 16, and that's going to be, if I had 10 groups of 16, I would have 160, right? So I could do that if we chose to. I could say, well, let's just leave it like that. If I subtract that, then I end up with borrowing here. We have 272, which means what? I could do another group of 10, group of 16 there. Anything wrong with that? No, I probably should have done 20, but it's okay. So 2 minus 0 is 2, 7 minus 6 is 1, and 2 minus 1 is 1. I can't get 10 more groups out of this, can I? Because I need 160, it's too small. So to think about what goes in there, again, I don't know, let's just start with a 5. Let's just pick a number to go with. So 5 times 16 is actually going to be equal to 80. So I know that's pretty good. So we subtract, and we have 32. And in this case here, 16 times 2 actually is 32, so I have 0 left over. So now when I add this up vertically, 5 plus 2 is 7, and 1 plus 1 is 2. We end up with 27 as an answer right there. Okay, so that's using partial quotients to help us solve these problems here. Are there other ways? There certainly are. We could use the base 10 blocks, and later on we can use long division, but just showing you how this works here. So in summary, we can find the quotient 345 divided by 3 in different ways. One way is to do a diagram. We take the 345 and we divide that up. We have the 300 and we have the 40, and we take that extra tens block and we unbundle it and we make it up into 2 groups of 5 here, so we have equal number of ones, and we end up with everybody having, in this case here, 100 and then 15 all together, right? So we noticed that in order to do this, we had to unbundle, or what we call decompose, one of the tens into 10 ones in order to make that work. So we can show you how that works there with the base 10 blocks, but we can also use the method of partial quotients to show the same thing. So the partial quotient method says I can have 3 groups of 100 and take that out. Everybody gets there. I can see with the 300 right away. Think about your blocks. There were 3 groups of 100, right? So we're going to break those apart. Group 1, group 2, group 3. Great. Everybody, there were 3 groups of 10, and so we could find that out there. With the tens blocks, there were 3 groups of them, got 30. And then there were 3 groups of 5 left over for 15, and that's how we had the 5 there as well. So this all works out just fine there. Are there other ways of doing it? Sure. And again, you could use different methods, right? That's the 100, 10, 55. I can also do 15 groups of 3 for 45. Leave me 300. I could do 50 groups to get that, and another 50. This adds up to the same way as that one. So it doesn't have to be always 110 and 5. There are other ways of getting the same answer there. Okay? So it depends on which way you do it. There's different ways of calculating that out, but they do work. That's why the partial quotient method is a good way of doing things, just so you can see different ways of arriving at that same answer there. Okay? Both are effective. If, however, the dividend and divisor are larger, as in 1,248 divided by 26, then the base 10 diagrams will be time consuming. So base 10 diagrams are only effective when you're dealing with smaller numbers. The bigger the number gets, you probably don't want to use that. Okay, that's it for today's lesson. Let's pause there and give you some time for the homework, and we'll come back and check it together in just a few minutes. Alright, here's one way to find 2,105 divided by 5 using partial quotients. We can see that right here. 2,105 divided by 5 using partial quotients. Show a different way of using partial quotients. Okay, cool. So, meaning this, we're going to go ahead and go 2,105. We're going to divide it by 5 and look at some different ways we can group this up. I could notice that there are 200 groups of 5 inside of here, and subtract that instead of 400, and making that 5011. Inside of 1,105 is another 200 groups of 5. We could subtract that again, 0, 1. Inside of 105, I could notice that there are at least one group of 5. 1 times 5 is 5. Leaves me with 100, which leaves me then with 20 groups of 5 to make the even 100 there. Just zero it out. When I add that up, I still end up with 421 when I add up vertically there. Are there different ways of doing it? Sure there are. So just showing some different ways of arriving with those partial quotients. Number 2. Andre and Jada both found 657 divided by 3 using partial quotients method, but they did the calculations differently as shown here. How is Jada's work similar to and different from Andre's, and explain why they have the same answer. So let's take a look at some of the differences here. We know that the quotients are exactly the same, so nothing has changed here. This is the same. This is the same. We also see that their solutions are the same as well. What's different is the way that they went about getting these numbers here. We know that the 9s are the same both times, but here is 210, and here's a different way of doing 210. So for Andre went ahead and first found 200 groups of 3 to go from 657 down to 57. So he took a big chunk out right away. Jada may not have recognized that. She may have done, let's do a 50 first to get this down to, well, for whatever reason, 507, and then she took out another 300. So she just went a different method there, okay? They both subtracted multiples of 3 a lot of times. These are all multiples of 3 all the way through, okay? Then they added the multiples together to get their solution, 219. That's good there. The difference is that they just had different multiples of 3. Why do they have the same answer? Well, because their multiples of 3 ended up adding or combining together to be the same number. So that's kind of how that works out there. You can explain it in your own words, but it works out. So which might be a better way to evaluate 1,150 divided by 46? Drawing base 10 diagrams or using partial quotients? I would go with partial quotients. Why? Okay, it's just too big for base 10. That's my reason. That's a lot of blocks to have to divide up into 46 groups. That would just take way too long to do. So that's why you want to use partial quotients when you can, or eventually long division as well. Okay, here's an incomplete calculation of 534 divided by 6. Write the missing numbers, marked with a question mark. That would make the calculation complete. Okay, so first of all, we have 80 groups of 60, which is 480. So we subtract. 4 minus 0 is 4. We have to borrow from there. 13 minus 8 is 5. Okay, 9 groups of 6 is 54. And left you with 0. And we add that up, 9 and 8, and we're good there. And that's it. That's all there is to it. Number 5. Use partial quotient method to find this one here. So let's go 43 and 1032. Okay, so 43. Again, you can use what you know. So let's just say 43 is about 50, right? And so 2 groups would be about 100. Okay, so 2 groups get you to 100. We can go to 1,000 though. So let's just go for now. Let's just go ahead and go with 20 groups. Okay, let's go with 20 groups for now. Okay, 20 groups. So put a 0 there, and then 43 times 2 is 86. We have 860. So 20 groups of 43 is 860. Subtract. We have 2. We're gonna borrow. 13 minus 6 is 7, and 9 minus 8 is 1. Inside of 172, if I'm estimating, with like 4 times 4 is 16. So let's see what happens if I have 4 groups of 43. 4 times 3 is 12. We carry the 1. 4 times 4 is 16 plus 1 is 172. Works out great. So now when I add this up, we have, going this way, 0 plus 4, 2 plus nothing, and we would say 24 groups there. So that's our answer for number 5. Okay, number 6. A lot of math here. Which of the polygons has the greatest area? A rectangle, like that has these dimensions, a square, which is 4.6 times 4, and then a parallelogram, the width and a base and a height, or a triangle with the base and a height there. So you have to do 4 different equations, okay? The first one is 3.25 times 6.1 to get an answer there. The next one, it's a square, so 4.6, and we're going to multiply that by, oops, why did I do that there? 4.6 times, that's funny, times 4.6 to get the area of that one. And then we have 5.875 times the height, 3.5. And then finally over here, we're going to do 1/2 times 7.18 times 5.4 there. Okay, so each one of those is going to be a little bit different in terms of the solution that you get. Okay, hang on one second. And 4 and 2, 16, 18, 6, 7, 8, 21. Okay, so when you multiply these out, this first one ends up being at 19.825. For a square, you do 4.6 times 4.6, and I had to redo that real quick on my notes. I ended up with 21.16. This one here, I multiply those together, and I end up with 20.5625. And then finally this one ends up with 19.386. So my second time working for this one, I would say the square has the greater area of 21.16 if I'm doing the math right there. Okay, double checking 36, 24, 27, 0, 4, 2, 16, 18, 6, 11. Yep, there we go. Cool. All right, number 7, our last one. 1 micrometer is a millionth of a meter. These come up a couple times here now, haven't they? Okay, a certain spider web is 4 micrometers thick. A fiber in a shirt is 100 thousandths of a meter thick. Okay, so which is wider, the spider web or the fiber? Explain your reasoning. Okay, so 1 micrometer is 1/1,000,000th of a meter. Okay, so this guy is 4 micrometers, which is 4 of the 1/1,000,000th. 1, 2, 3, 1, 2, 3, right? So it's 4/1,000,000th of meters there. The fiber in the shirt is 100 thousandths of a meter. So 100 thousandths of a meter, like that one there. Okay, which one's going to be bigger? Well, the fiber shirt's going to be bigger. So we would say the fiber one's going to be bigger because it's a larger number. 1 over 100 thousandths is greater than 4 over a millionth, basically. Okay, so how much more wider it's going to be? Now, this is one where my answer here, I did a couple times, is different than what my teacher's book says. Maybe I'm right, maybe I'm wrong. If I'm wrong, that's okay. I can live with that. All right, so first of all, this one is 1 over, in this case here, 1 over, or, well, 100 thousandths, which is going to be point. We have 10, 100 thousandths, 10 thousandths, 100 thousandths right here. This is the millionth, so I have to think of this as being tenths, hundreds, thousand, 10 thousandths, 100 thousandths, and then millionth right there. So that's the 4 millionths, and that's the 100 thousandths. So I can add a 0 there to start subtracting to find out what the difference is going to be. And that becomes 0, that becomes 10. So you're going to put 0, 0, 0, 0, 0. And again, we're still in the millionth place. So the difference should be 6 millionths difference. Okay? Or 6 micrometers. Another way of thinking about that one there. Alright. And that is it for today's lesson. Hope you have a great day, and we will see you next time.